I was driving home from work a couple days ago, and it was kind of dark outside because it's getting dark early now that the wintertime's almost here, and came across this older Schumacher battery charger, a wheeled battery charger, just sitting by the side of the road. I'm not sure how long it was there. I've always wanted one of these larger chargers, so I whipped the car around, pulled over, and quickly put it in the trunk and got it home and never looked back. And this charger is in the condition that it was when I picked it up. Haven't really had time to do much with it, and it looks to be in pretty sorry shape. It looks like it was kicked to the curb rather unceremoniously with just tons and tons of caked on mud. At least I hope that's mud. It looks like it spent considerable time outside, tipped over more than likely because it's got mud all over the back of it and everything. And it looks like it's just been very well used. It's got the wrong kind of fasteners in here for the handle, so somebody jerry-rigged that. But I figure, well, it was free, so why not go ahead and see if I can clean this thing up and get it to work. Perhaps maybe it already works. Looks like most of it's already there. The battery cables look to be in good shape. Nothing's frayed or anything like that. There does appear to be a little bit of damage on the wiring, but no exposed conductors. That looks like the ground wire right there. This would be easy enough to fix if I find out that it's worth fixing. Just cut off a section of it and move this on in and get to where there's new material there. Plug looks to be in good shape. I can bend those back. So I've always wanted to see what was inside one of these things. I think I've got a pretty good idea. It's probably just a regular center tapped transformer, rather large transformer, and a full wave rectifier, probably 2 diodes, and a heat sink, and various other goodies. This one looks like it can do various charging modes, 12 volt 2 amp, 12 volts 10 amp, or 6 volt, and then all the way up to 50 amps or 225 amp start. Plus it's got a timer and some amp meters and battery condition meters, and then your 6 and 12 volt selector switch. These meters are quite faded and the plastic is kind of warped around the bezels, so this thing has spent a lot of time out in the sun, it looks like. I was going to say it might have been near a space heater, but that wouldn't have caused the ink to fade. So this thing probably spent most of its life outside, judging by the amount of corrosion on here starting to come through. That's what it looks like on the front. Schumacher makes pretty good stuff, nothing wrong with it. I've always wanted one of these larger chargers because I actually do have pretty good luck with car batteries, but you never know when you might need to have a booster charger like this if you're doing some testing and you don't want to wear the battery all the way down. You could use one of these much more powerful booster chargers to kind of help you out. This one looks like it's a model SE-2158 and actually made in the United States. That's unusual. So, very encouraging. Hopefully there's nothing wrong with this. We'll find out as soon as I get this thing a little bit cleaned up and taken apart. Looks like there's 3 screws on that front side, 3 screws on the back side, and likewise on the other side of it as well. These battery chargers, these analog type chargers, tend to be pretty simple, and I should be able to get this thing repaired as long as there's nothing major wrong with it. The Achilles heel would be if the transformer is burned out. If that's the case, I'm done. I don't think I'll be able to find a replacement transformer, but I can certainly get diodes and fuses and things like that. Switches, if they're bad, they can usually be cleaned. This looks like just a regular rotary switch. So let's get this thing apart and see what's inside of it. Now we can see the inside of this thing, and it's pretty simple and straightforward, but nonetheless very interesting the way it's designed. I've never been inside one of these large wheeled chargers before. As you can see, it's a complete disaster inside. It has not been very well taken care of at all. I've got a wasp nest back there and several mud dauber nests hanging around. All kinds of debris and grass and everything else. Let's get that out of there. Who knows how long this has been sitting outside. So, good news is, at least upon first glance, the transformer would seem okay. The windings don't really look in that bad a shape. Let me get a flashlight for that so we can see it better. I believe that the top winding is the primary, and it looks like it's got two sets of secondary windings. It's kind of hard to get all this in the frame. And then those secondary windings are gained together on those three bottom connections. And then the three bottom connections basically form a common, and they go to an inductive type ammeter. That's how it's measuring the current. And they're all tied together to these two circuit breakers, and that forms your negative. Sorry for the poor video quality. I don't really have a whole lot of room to squeeze a camera in here, and it's awfully dark. Looks like the power hot lead comes into this switch here, which is the timer apparently, and then comes on down in here and goes to this first lead of the transformer. And it looks like all the various voltage selections and current selections that you have available are controlled by various taps on the primary side of the transformer. And then for your positive, it looks like once again they have taken what looks like two separate secondary windings and ganged them together and formed a full wave rectifier and tied that to the positive lead that goes to the battery. So it looks like the circuit breakers are breaking on the negative, and as long as these switches are okay, we should be in good shape, and as long as the transformer is okay, we should be in good shape. This will be the Achilles heel. The project is all over with if this transformer is burned out, because I'm sure this is not replaceable unless you want to buy a new unit. If the switches are bad, I can always bypass these switches and, you know, maybe put a row of toggle switches across here or something like that, or maybe even find one of these replacement switches. But the transformer is the heart of the whole system right here. This is just a regular shaded pole motor for the fan. Kind of nice that they have a fan in here. The bearings don't look to be in too bad a shape, surprisingly enough. I've not done anything to these. And it spins for a good long while. This is just like the kind of motor you'd have in your bathroom vent fan, something like that. So before I apply power to this thing and try it out, I'm going to go ahead and use the multimeter in the continuity position there. And I'm going to go ahead and check for continuity across these windings, as well as check out the condition of these diodes. I think that the weakest part of the whole arrangement here is going to be the diodes usually. They don't look like they're beefy enough diodes, quite honestly, to handle 225 amps. That's seems like it's asking an awful lot of these little guys. But anyway, I'll go ahead and test those. The circuit breakers is just a little bimetallic strip inside here. These look kind of like automotive type circuit breakers, and they're if that's the case, they're going to be self-resetting, so I wouldn't expect there to be any issues here. So if this thing were to have any issues at all, it'd be burned out transformer, bad switches, one or more bad switches, or the diodes. And truthfully, this transformer looks a lot beefier than the diodes are, so if you were to short the two cables together, my guess is these two diodes would act like a fuse and blow up and protect the transformer. But we'll see what we got. I'm going to go ahead and keep a lead on the comment on the transformer and just make my way down and test each one, and you guys should hear a beep with each test. If you guys can see. So we'll put this on common. Now we'll go to our first one. Just making sure the meter's on. This thing is so crusty, it's hard to get a good connection here. Alright, looks like the primary side of the transformer is looking good. And now the $20,000 question, what kind of shape are these diodes in? I'll try to rearrange the camera so you guys can see. Basically what we're going to be doing to test the rectifiers. They only allow current to flow in one direction, so basically I'm going to put the leads on the continuity tester, one here and one right here, where I have looks like a more clean connection, and then I'll reverse them and do the same thing. I should have continuity in one direction and no continuity in the other direction. I'm also going to test between this connection and that connection to make sure that the secondary of the transformer is not burned out. I've tested the primary, and the primary looks to be okay, but I don't know about the secondary. Kind of cramped in here. So no continuity there. We'll take our leads and reverse them. No continuity there. So at a minimum we already know we have one bad rectifier. We'll reverse the leads once more, go to the second rectifier. No continuity, which I would expect, because this is the positive side. I'm having to press on these really hard because everything's so dirty. And no continuity there, so we know that our rectifiers are open circuit. And now we'll go between the secondary leads on the transformer, and we do have continuity. So that's very good. So this thing looks like it may be salvageable. I know now the reason why this failed is more than likely the rectifiers are opened up. I think I'm in good enough shape now to go ahead and apply power, and that'll further test everything out, including the fan, and see if I get 12 volts AC across that secondary. I don't see any burned wiring or anything like that. Anytime you find something like this, especially in this kind of nasty shape. You always want to open it up and make sure that somebody else hasn't tried to quote-unquote fix it. And you want to check for obvious problems like burned wiring and things like that, because you don't want to burn your house down, but everything seems to be okay. So I'm going to go ahead and get an extension cord, and we'll fire this bad boy up and see what we got. Okay, now I got the unit plugged in, such as it is, and dirty as it is, and I'm set up to measure voltage across the secondary of the power transformer, and just studying how the wiring looks. It looks like we have to make use of both switches. So we'll go ahead and set the timer and see if this thing energizes. So that's encouraging. That little fan puts out quite a bit of wind, actually. And it looks like we don't have any voltage, because now we have to go to the second switch here and make a selection. So we'll go to 6 volt 50 amp, and hope to goodness that the transformer is not going to blow up on us, because it looks like there's actually no power applied to the transformer, even though the timer is on, just the fan is running. So in the 6 volt position we have about 9 volts, and looks like nothing's getting hot, which is good. And keep in mind this is 9 volts AC, as you can see here, because we know that the rectifier is completely shot. It's all open circuit. And now we'll test another tap. We'll go from 6 volt 50 amp to 12 volt 2 amp. And in that position we have about 10 volts AC. Looking good so far. And we'll go to this one here, 12 volt 10 amp or 6 volt 125 amp start. And looks like we don't have anything. I'll have to troubleshoot that further. Either the switch is bad and not applying power to the appropriate leads on the transformer, or that particular tap on the transformer is bad. I didn't catch it on the continuity test. Now we'll go to 12 volt 50 amps. $16 volts basically. Good thing I didn't have my trusty test light hooked up to it at that point. And now we'll go for the gold, 12 volt 225 amp. And we're up to 21 volts. This would not be a very good charger to use on a computer controlled car, to be sure. If you put a battery across that, the voltage will drop a little bit, but I would not feel very comfortable running this thing on a computer controlled car in the start position. It'll be interesting to see what that does after the new diodes are put in. But so far, I think I can bring this thing to life. I'm going to knock this thing back to 12 volt 2 amps, get to 10 volts, and use my test light to see if it's actually putting out that kind of, see how much current it puts out basically. I've seen cases where bad components would give you a voltage reading but not enough current to do much good. And we have light. So this does look very promising. I think I can go ahead and bring this thing back to life after a really good cleaning and some new diodes. I'm going to see what I can find out, see where I can source some replacement diodes, and probably I'm inclined to put much larger diodes in this thing, give us an extra long life, and have myself a fairly good battery charger. Something I've always wanted, one of these wheeled chargers. I've got a small 10 amp charger that I use, but definitely nothing on the scale of this. The transformer is smaller than I thought it would be for such a claimed current rating, but then again, unless you have problems, you're not going to be cranking on the engine but for so long, and you're also going to have the help of a car battery as well too, so the transformer is not going to carry the entire load, or at least it shouldn't. And the same goes for the diodes. So it looks like that's the primary failure of this thing, is the rectifier went bad, and I guess the people thought that this thing is just too old and crusty, it's seen better days, and best to go ahead and get rid of it. But I think for a couple of bucks I can go ahead and replace these things and have myself a pretty nice battery charger. It's going to be pretty hard to unsolder those connections. That's going to take a pretty high temperature to get that thing out of there, as corroded as it is. It'll be interesting to see the 12 volt 225 amp. It'll be interesting to see how far down that 22 volts goes when connected across the battery. Hopefully it'll go down to about 14 or 15 volts to where you can use this on a modern car, but for right now I'm inclined not to do that. Looks like our battery reading is, our battery meter is actually working. Looks like we're in the good. And I cannot see the meter here because it's so crusty. But I'm going to go ahead and clean this thing up. See if I can source a couple of rectifiers. I like International Rectifier. That's usually, I've had good luck with them, so I want to see if they make a replacement diode for this, or a substitute diode. And put some heatsink compound on here, clean this up real good so it dissipates heat nicely. And see if I can bring this thing back to life. So stay tuned for that. I actually ended that video a little bit early. I wanted to make an amendment to what I said earlier. After I ended the video, just for the hell of it, I went ahead and tried to measure voltage across the output of the rectifier. Sure enough, it's actually working. The rectifiers are good. I even ran my test light on it to make sure they would handle the current, and they did. I think that the issue was these connections are so filthy and corroded, I wasn't making good enough contact to give these diodes a proper test. I also went ahead and troubleshot this switch, and why there seems to be no voltage on the secondary in this position here, and it turns out to be a bad switch. In this position here, and then measuring all the way from common to each one of these connections, there's no voltage at all. Interestingly, if I go to the start position, I get up to close to 300 volts across these leads. It's interesting the magic this thing is doing with the transformer. I'm not sure if it's somehow got two primary windings in addition to two secondaries and somehow adding them together, but that's why that voltage was so high. We'll go to that position there. And we're getting about 18 volts on the 12 volt 225 amp section. So this thing is actually working properly with the exception of the switch being bad in that position there, which is basically the most commonly used position, 12 volt 10 amps. So my guess is the contacts inside here are burned out. I'm going to see if I can get a new switch for this thing. That's a pretty specialized part, I'm sure. And I may go ahead and replace these rectifiers anyway, even though they're clearly working. We've got DC voltage. I'm actually quite amazed. Most of the time these battery chargers get abused. And I'm just astonished that these rectifiers have taken that kind of punishment after all these years and they still work. I'm going to get on the internet, see if I can find a new switch, and clean this thing up and kind of do a rebuild on it. I think I got a good battery charger for free.